Good morning, students. Hope you all are fine by the grace of God. I am Manikant Mishra, Modern English School, New Area. Once again, welcome to you in e-learning classes. So, though we have already discussed about the displacement reaction and cause of displacement reaction. But once again, I would like to recap it or revise it the same. First of all, let me define what is a displacement reaction. More reactive metal displaces less reactive metal from their salt solution. As for example, like aqueous solution of aqueous solution of copper sulfate, when zinc metal is added, we find, and the aqueous solution of copper sulfate is blue in color. When we add zinc metal, after sometimes we see the slowly or gradually that blue color of aqueous solution of copper sulfate, blue color gradually starts to fade and forms zinc sulfate, which is a colorless. Aqueous solution of zinc sulfate, which is a colorless. So gradually fading of copper sulfate, gradually the blue color fading indicates that the reaction is proceeding. Reaction is taking place continuously. So now this colorless salt solution appearance indicates that there is a reaction is taking place. Also on a zinc metal, this brownish substance is deposited over the zinc metal. The brownish substance is appeared. That brownish substance is nothing but it is a copper metal. So what happens in this reaction? This aqueous solution of copper sulfate convert into copper solid by taking 2 electron. This copper 2 aqueous solution takes 2 electron and convert into copper solid. Aqueous copper takes 2 electron and convert it into copper solid, and this zinc solid lose 2 electron and convert into zinc aqueous. Zinc solid convert into zinc 2 plus ion, and this happens in solution. So zinc 2 plus is possible in aqueous solution and releases 2 electron, and these 2 electron only used by copper 2 ion and convert into copper metal. So it means here it shows that the zinc is more reactive than copper. That's why this reaction is proceeding, and one of the indicator is what here, the change of color. With the change of color, one can understand that yes, reaction is taking place. Not only the change of color, but here the brownish substance appearance, that is also of the deposition of a copper metal. So these two things make us aware that thus in fact the reaction is taking place. But if you take it reverse, like if you take a colorless solution of zinc sulfate and add copper metal, no reaction, no any change takes place. If you take it in a reverse situation, like aqueous solution of a zinc sulfate, which is a colorless and copper metal, if you add, then even half an hour or an hour or after a day, we observe, then we find that there is no change, no appreciable change, no any change takes place. So this indicates that there is no reaction takes place between aqueous solution of zinc sulfate and copper metal. Why? Because copper is less reactive than zinc. That's why copper is unable to displace. Copper is unable to displace zinc from zinc sulfate. My dear student, now I would like to focus why it happens. So I will try my level best to make you understand in the simplest way. So, first of all, the tendency of losing electron. The different metals have a different tendency of losing electron. Why it happens? The very first factor is size of atom. Size of atom. One of the factors on which the tendency of losing electron and forms electropositive ion depends on the size of atom. And this second thing is ionization enthalpy. Ionization enthalpy. Now when we say size of an atom, what does it mean? The distance from the nucleus to the outermost shell. The distance from the nucleus to the outermost shell. Now the second thing is ionization enthalpy. What is ionization enthalpy? The amount of energy required to remove an electron from an isolated gaseous atom. The amount of energy required to remove an electron from an isolated gaseous atom. So if suppose we have metal M, which is in the solid state, has first of all it has, by giving heat energy, it has to convert into solid metal into the gaseous metal. And the energy used is called enthalpy of sublimation. Is called enthalpy of sublimation. Used is here delta H. Delta H stands for enthalpy of sublimation. Enthalpy of sublimation. Now this gaseous atom loses electron and convert into M plus G plus A. Here the energy used is called ionization enthalpy. Here from the gaseous state of metal, the electron is need to lose, and for that the energy we supply is called enthalpy of sublimation. Some of you last time you have objected that like a calcium proton, neutron, this 2, 8, 8. K cell, L cell, M cell, N cell. Now we are talking about the calcium metal. Now in a K cell there are 2 electron, L cell 8 electron, M cell 8 electron, and N cell 2 electron. Now after losing one electron from calcium, then it becomes calcium ion, 1 unit of positive charge. Now after removal of one electron, there is a contraction in size takes place. Now again, calcium loses one electron and convert into calcium positive ion or calcium ion having 1 unit of a positive charge. The energy involved is called first ionization enthalpy. Now after losing one electron, there is a contraction in size takes place because always there is a force acting between the nucleus to the outermost cell simultaneously. These two forces act simultaneously, that electron tries to pull outwards the nucleus and the nucleus tries to pull the electron towards its center. So these forces are balanced, as well as number of electron and number of proton are equal. Here one of the electron from the calcium has been removed and it has converted into calcium ion having 1 unit of a positive charge. So after the removal of one electron, there is a contraction in size takes place. Now due to small size compared to the first case, now in second case, now it represents the calcium ion. This model represents calcium ion having 1 unit of a positive charge. So now there is a strong electrostatic force of attraction is acting between the nucleus and the outermost cell. Earlier it was also acting, but now after losing one electron becomes more stronger. It means now in order to remove the next electron, so again the energy required will be more than. Now energy required for the removal of the second electron will be larger than as compared to the first one. So the value of IE2 is what? Second ionization enthalpy is larger than first ionization enthalpy. So what I am trying to make you understand, my dear student, this gives a reluctance to lose the electron. This delay the losing of electron and makes the element less reactive as compared to those metals which can easily lose electron, like sodium and calcium. Sodium has 281. Or if you talk about the potassium, 2881. Potassium has to only lose one electron, but at the same time calcium has to lose 2 electrons. That's why potassium readily loses one electron and acquires a stable noble gas configuration, whereas calcium has to lose two electrons in order to acquire the nearest noble gas configuration. So losing of second electron require higher amount of energy, and this makes calcium or likewise metal, likewise element less reactive compared to others metal which need to lose one electron, and their size is bigger as compared to sodium, but sodium has to lose one electron. On the other hand, calcium has to lose two electrons, and that losing of two electrons becomes a little tough as compared to losing one electron due to consideration of energy. That's why calcium is less reactive as compared to sodium. If there is any doubt, please let me know during your online time, that is 9 a.m. to 11 a.m. Thank you. Have a nice day.